Hello everyone. Today your class number 9 for electrical machine 2. Class number 9 for electrical machine 2. So last day I have discussed the rotating magnetic field produced by three-phase balance system. Okay, that means a three-phase supply is given to a electrical system or electrical motor. You can say it is a three-phase induction motor, and there will be a rotating magnetic field is developed inside the air gap in between stator to rotor part. Okay, so here I have to discuss the rotating magnetic field produced by two-phase winding. Okay, two-phase winding, or you can say alpha beta system. Okay, so rotating magnetic field produced by two-phase system. That means two different phases which are 90 degree apart from each other. In case of three-phase system, they are 120 degree apart from each other. Okay, so here it is 90 degree apart from each other. They are 90 degree apart from each other, or you can say two-phase alpha beta system. So alpha beta system, or you can treat it as. Okay, so let us assume a rotor part. Suppose two-phase three-wire system. It is two-phase three-wire system. This is a two-phase three-wire system. Why two-phase three-wire system? Suppose it is a alpha phase, beta phase, and neutral. Okay, so suppose there is an iron part where the installment of the wires looks like, suppose one of the phase is installed over D axis, along this D axis, and another one is installed along Q axis. Okay, so alpha neutral. Okay, so for this section it is alpha phases are installed, right? And for beta phase I would like to express in color by color changing. Okay, so you can say this is your alpha axis, this is your beta axis. Okay, so this is your alpha axis, this is your beta axis. Okay, so right angle, they are right angle to each other. Okay, so let us consider, right, let us consider alpha b. Let us consider alpha b the reference phasor. Alpha b the reference phasor. That means if we want to express it in, suppose alpha is taken as, okay, this way, omega t, this is your alpha, and beta will be 90 degree phase shifted, so it will be shifted by 90 degree. So this is alpha, it is beta. Okay, so if we want to express, if we want to find the resultant field, so this alpha flow produces phi of a. Suppose the flux produced by alpha is equals to phi of a. flux produced by alpha axis, and phi of beta equals to flux produced by beta axis. Okay, so let us consider it is phi of A, it is phi of B. So resultant flux has, so what is the resultant flux direction? So suppose we are taking is at this instant, sorry, we are taking at this instant, where B will be maximum, and see, it is 0 degree, it is 90 degree, it is 180 degree, and it will be 90 degree phase shifted, that is 270 degree, right? So this point is 270 degree. 270 means what? 80 plus 90, so it will be, I think at that situation, okay, so it will be 90 plus 90, it will be maximum. Okay, so actually this graph is not clear, so you have to redraw the graph. So graph will be drawn like this way, that okay, from 90 to 180, right? So it will be maximum when it is 0. It will be maximum when it is 0, and when it is maximum it will be 0, and when it is 0 it will be negative maximum, right? So by this way you have to draw it. Okay, so now you have to trace. So how to trace it? So make a projection line over here, and then again the projection line from here, okay, and then make a projection line from here, and another projection line from here. Okay, there are these 4 sections, we are taking these 4 sections. So for this first section, what will be the direction of the phi of A? Suppose this is phi of A, this is phi of B. Okay, sorry, phi of alpha, this is phi of beta. Okay, so A direction will be upward, so from E will be maximum positive, so phi of alpha will be maximum positive over here at that situation, and then it will be 0, so the resultant direction will be this one. And after moving some time omega t, that is when 90 degree, then it will be this, when 180 degree, then it will be at this situation, and at this situation B will be maximum, so B will be maximum and alpha will be 0, and again it will be alpha will be negative, and B will be 0, and here alpha will be 0, B will be negative. So at that situation it is in this direction, at that situation it is in direction, at that situation it is in direction, at that situation it is in direction, that is, it is rotating, like, right? So it is rotating, so flux is rotating, right? This is phi of 90 degree section, it is phi of 180 degree section, it is phi of 270 degree section, it is phi of 360 degree section. So every 90 degree it will rotate by 90 degree, right? So flux is rotating with in the air gap. So two-phase system can also produce a flux which is rotating in nature. Okay, two-phase system also producing a flux which is rotating in nature, and this system is called alpha beta system, and it is very much important where it is applicable. This concept is applicable on your single phase induction motor system. Okay, in case of your single phase induction motor or Cron's primitive machine. Cron's primitive machine, once you have to understand Cron's, K-R-O-N apostrophe, Cron's primitive machine. Okay, So Cron's primitive machine is applicable. In Cron's primitive machine, this concept is applicable. There are two-phase systems where they are where they can produce a rotating magnetic field inside the air gap in between stator to rotor part. Okay, so this is the rotating magnetic field produced by two-phase system. That is the alpha beta system. Okay, so now I will move into the numerical part of this chapter. Okay, so the numerical part is very easy. For within this chapter the numerical part is very easy actually. Okay, so actually these numericals are all related to the three-phase induction motor and single-phase induction motor, this type of concepts. Okay, so trying to develop some numerical which are related to this magnetic fields generation. Okay, so please wait, I will give you some numericals and which you have to solve, or we can solve by discussing. Okay, so let us write. Okay, so once before start the numerical, I would like to recall one formula, that is Ns equals to 120 Fs by P, right? Ns equals to 120 Fs by P. What is the meaning of that? The meaning of that is the synchronous speed. This is called synchronous speed, right? This is called synchronous speed or speed of rotating magnetic field. And Fs equals to frequency of rotating magnetic field. And P equals to number of pole present in the stator field or field system or the field system. Okay, how many number of poles are there in field system? Okay, so one Ns equals to 120 Fs by P. This is your formula. So now write problem number 1. So what is the problem number? Right, a slip ring induction motor. A slip ring induction motor consists of a slip ring induction motor consists of 8 poles. So a slip ring induction motor consists of 8 poles. Having stator frequency 50 Hz. Having stator frequency 50 Hz. Then calculate the rotating magnetic field speed. Then calculate the rotating magnetic field speed. Then calculate the rotating magnetic field speed, that is Ns, in RPM and in rad per second. So you have to find this Ns in RPM also and rad per second, and also in RPS. See, for RPM I have written in capital, and for RPS I have written in RPS, that is rotation per second, within second, and Ns equals to rad per second. Rad per second is one of the unit. So these 3 units are basically used in this to solving the Ns. So Fs equals to 150 Hz, P equals to 8 poles, and clearly you can say Ns equals to 120 into 50 by 8. So your multiplication will be by cancel out by 4, it will be 2, and 4 will be 30, 2 will be 15, right? 15 into 50, that is 750 RPM. 750 RPM is the speed of synchronous speed for the field flux. So basically the unit will be RPM. Okay, the unit will be RPM, and if we find the speed in RPS, then we can express it as a small n of s. Okay, so n of s means the formula. What will be the formula? How to find this speed in rps from the rpm? So it is very easy actually. How? Because rpm means what? Rpm means within, right? Use the unitary method. In 60 second. So this statement means in 60 second. In 60 second rotation equals to, or number of rotation equals to 750 times, right? So in 1 second it will be 750 by 60. So what about the formula? So ns can be written in, so capital Ns by 60, that means 120 fs by p into 60, that means 2 fs by p. So this is your another formula. Ns equals to synchronous speed 2 fs by p. Okay, so 2 fs by p. So ns equals to, you can say 2 into fs by p, that is 2 into 50 by 8. That will be how much? It will be cancelled out by 4. 2 first, 25 and 4, and again it will be 225 by 2, that is 12.5 rps. Okay, so and it is rpm, so ns equals to 750 rpm, that means 12.5 rps. And for rad per second unit you have to solve it. So what will be the formula of rad per second? So rad per second means, wait, see what is rad per second concept. How you can find the speed in rad per second? See, so one rotation equals to 2 pi radian, right? Once complete rotation will follow 360 degree angle, that will be 2 pi, right? 2 pi radian. So 360 degree means 2 pi, right? So one rotation 2 pi. So theta equals to 2 pi. Okay, and so therefore, so if we express it that ns times rpm, that means within a minute 750 times, or make it general, ns times rotation, right? Within a minute ns time rotation, that is in 60 second ns into 2 pi angle rotation, right? In 60 second ns into 2 pi angle rotation. So in 1 second ns into 2 pi by 60 angle rotation. So your formula is nothing but, so speed in rad per second, this is called omega s. Okay, this is the speed of rotating magnetic field in radian per second. In radian per second. So therefore omega s equals to, ns equals to what? 120 fs by p. 120 fs by p into 2 pi by 60. Just putting the formula of ns over here. By putting the formula of ns over here, 0 0 will be cancelled out, 6 cancel out 2, 2 to the 4, 4 pi fs by p, right? 4 pi fs by p. So your another formula is omega s equals to 4 pi fs by p. So there are three formulae. To express the magnetic field speed. So first one is ns equals to 120 fs by p in rpm, and ns equals to 2 fs by p rps, and omega s equals to 4 pi fs by p rad per second. Okay, so these three formulae you have to remember for finding this type of problems. Okay, and this type of problems will come to your MCQ based question. Okay, so for this case, for this numerical, so your answer was ns equals to 750 rpm, small ns equals to 12.5 small rps, and omega s will be equals to 4 into pi into 50 by 8, right? So your answer will be 2, that is 25 pi 25 pi rad per second. Okay, so these three answers will come to this numerical. Okay, which is very much easy. Okay, so this module consists of this type of numericals and the theories which have already been taught. So this module up to this much. Next module I will start, that is a 3-phase induction motor. So your next module will be 3-phase induction motor. Please wait for that. Next day, that is class number 10. I will start the class number 10 in next class. Okay, so thank you. Today's class up to this much. Thank you.